Our lesson 9.3 is about waves behavior in a boundary. Lesson 9.3 has the following goals. Goal number 1, to describe how waves behave when they meet an obstacle, pass into another medium, or pass through another wave. Goal number 2, to determine what wave property stays constant as the wave moves through a boundary. As a wave travels through a medium, it will often reach the end of the medium and encounter an obstacle or perhaps another medium through which it could travel. The behavior of a wave upon reaching the end of a medium is referred to as boundary behavior. A boundary is a place where conditions change. What a wave does at a boundary depends on the boundary conditions. When a wave crosses a boundary, what characteristics of a wave change? Is it the frequency, the wavelength, the speed, or the amplitude? The wave approaching a boundary is called the incident wave, while the wave sent from a boundary is the reflected wave. A wave that is bent passing through a boundary is called a refracted wave. Waves can interact with boundaries in 4 different ways. One way is by reflection. Wave bounces off a material and goes in a new direction. In refraction, wave passes through a material and bends. In diffraction, wave bends around or goes through a hole in a material. When plane waves go through a small hole, they become circular waves. In absorption, wave is absorbed by a material and may disappear. Boundary behavior. It is the behavior of a wave when it reaches the end of its medium is called the wave's boundary behavior. When one medium ends and another begins, that is called a boundary. Let us consider a situation when a boundary is fixed. What would you expect to happen at a fixed boundary? In this figure here, an elastic rope securely tied to a pole can be used to study the behavior of waves at a fixed end. One type of boundary that a wave may encounter is that it may be attached to a fixed end. In this case, the end of the medium will not be able to move. What is going to happen if a wave pulse goes down the string and encounters the fixed end? Look at the animation in this figure. Is it what you expected? In the fixed end boundary, the incident pulse is an upward pulse. The reflected pulse is upside down. It is inverted. The reflected pulse has the same speed, wavelength, and amplitude as the incident pulse. Let us consider now the free end boundary. What would you expect to happen at a free end boundary? In the figure, if the end of an elastic rope not fastened to the pole, then it will be free to move up and down. This provides for the study of wave behavior at free ends. Another boundary type is when a wave's medium is attached to a stationary object as a free end. In this situation, the end of the medium is allowed to slide up and down. What would happen in this case? Here is the animation of a wave pulse when it reaches the free end boundary. Is it what you expected? For the free end boundary, the reflected pulse is not inverted. It is identical to the incident pulse, except it is moving in the opposite direction. The speed, wavelength, and amplitude are the same as the incident pulse. Our third boundary condition is when the medium of a wave changes. Think of a thin rope attached to a thick rope. The point where the two ropes are attached is the boundary. At this point, a wave pulse will transfer from one medium to another. What will happen here? Here is the animation here showing the result when a wave pulse changes in medium from less dense to a more dense one. What changes as the wave moves through the boundary? What else happens at the boundary? We notice that in this situation, part of the wave is reflected and part of the wave is transmitted. Part of the wave energy is transferred to the more dense medium and part is reflected. The transmitted pulse is upright while the reflected pulse is inverted. Here, the speed and wavelength of the reflected wave remain the same, but the amplitude decreases. The speed, wavelength, and amplitude of the transmitted pulse are all smaller than in the incident pulse. Let us now consider a situation when the wave moves from a high-density medium to a low-density medium. What changes as the wave moves through the boundary? What is different from the previous example? Let's look at the comparisons between the characteristics of the transmitted pulse and the reflected pulse in the following situation. Here, the transmitted pulse in the less dense medium is traveling faster than the reflected pulse in the more dense medium. The transmitted pulse in the less dense medium has a larger wavelength than the reflected pulse in the more dense medium, and the speed and the wavelength of the reflected pulse are the same as the speed and the wavelength of the incident pulse. The boundary behavior of waves in ropes can be summarized by the following principles. The wave speed is always greatest in the least dense rope. The wavelength is always greatest in the least dense rope. The frequency of a wave is not altered by crossing a boundary. The reflected pulse becomes inverted when a wave in a less dense rope is heading towards a boundary with a more dense rope. The amplitude of the incident pulse is always greater than the amplitude of the reflected pulse. Thanks for watching. Please do not forget to subscribe.